Hello everyone. So let's start with mechanics today. And let's start the first topic of mechanics, that is motion in straight line. We will do it slowly, we will do it properly from the very basic. So let's start. Let's say there is a number line and a person stands on this number line at x equals to 0 at time equals to 0. And now the person starts moving in the positive x direction and we find the person at x equals to 10 at time equals to 10. So if the person have moved from x equals to 0 to x equals to 10, the person has moved 10 units forward. Now let's say this person does not stop here. From x equals to 10, now person starts moving in the backward direction. And this same person is found at time equals to 12 at x equals to 2. This means that in the first 10 seconds, the person have moved 10 meters forward. And in the next 2 seconds, that is from time equals to 10 to time equals to 12, in the next 2 seconds, the person have moved 8 meters backwards. So question is, what is the distance traveled by the person? So you will say the person have moved 10 meters forward and then 8 meters backwards. The total distance traveled by this person has to be 18 meters. Yes, sir. Now I ask you, what is the displacement of the person? You will say, sir, displacement is a vector quantity. Displacement is nothing but the final position vector minus the initial position vector. Here we are talking about motion in straight line. So simply the final x coordinate minus the initial x coordinate. So the overall displacement in this 12-second journey will be the final x coordinate after the 12-second journey, which is 2, minus the initial x coordinate, which is 0. So the displacement in 12 seconds is given by 2 meters towards right. Now they can ask you, what is the average speed? You know that the average speed is nothing but the total distance traveled upon total time taken. The person first moves 10 meters forward, then the person moves 8 meters backward. So the total distance traveled by this person is 10 plus 8, that is 18. Total distance traveled is 18. The total time taken is 12. What will be the average speed? Average speed will be total distance traveled upon total time taken. That will be 18 by 12. If you cancel them out by factor of 6, you get 3 by 2. So we can say that the average speed of this person is 3 by 2 meter per second. Now I am asking you, what is the average velocity of this person? You will say the average velocity is nothing but total displacement by total time taken. Total displacement by total time taken. The average velocity will be given by total displacement, which is 2 unit towards right, upon total time taken, which is 12 seconds. So the average velocity comes out to be 2 by 12, and 2 by 12 is nothing but 1 by 6 meter per second. Easy? Let's see next example. A person is moving with speed v1 for time t1 and then with speed v2 for time t2. Find the average speed for the entire journey. So the person first moves with speed v1 for time t1 and then the person moves with speed v2 for time t2. What is the average speed of this person? So you will say the average speed of person equals to total distance traveled upon total time taken. Person first moves with a speed v1 for time t1 and then the person moves with speed v2 for time t2. The total time taken in this journey will be nothing but t1 plus t2. What will be the total distance traveled? Let's see. So you will say, if the person goes with speed v1 for time t1, the distance traveled by the person will be nothing but v1 t1, right? If the person goes with speed v2 for time t2, then in the next time frame t2, the distance traveled will be v2 into t2. Hence, you can say the total distance traveled in the time frame t1 plus t2 is nothing but v1 t1 plus v2 t2. Average speed equals to total distance traveled, which is v1 t1 plus v2 t2, by the total time taken, which is t1 plus t2. I hope you find this easy. Let's practice the next example. If the person travels distance d1 with speed v1 and then distance d2 with speed v2, then determine the average speed of person. So if the person first travels a distance d1 with speed v1 and then a distance d2 with speed v2, then determine the average speed of person. We know that the average speed is nothing but the total distance traveled upon the total time taken. What will be the total distance traveled? The total distance traveled will be d1 plus d2. What will be the total time taken? We need to focus on the total time taken now. Time taken to cover the distance d1 with the speed v1 will be nothing but d1 by v1. You know the distance equals to speed into time. So the time taken to travel the first distance d1 with a speed v1 will be d1 by v1. So you can write d1 equals to v1 into t1. So the time taken to cover the first distance d1 will be d1 by v1. Now, time taken to cover the next distance d2 will be the next distance d2 upon the next speed v2. That will be d2 by v2. So from here you can say the total distance traveled by the person is d1 plus d2 and the total time taken for this journey is d1 by v1 plus d2 by v2. So we get that the average speed is total distance upon total time, that will be equal to d1 plus d2 upon d1 by v1 plus d2 by v2. You can cross multiply the v2 here, v1 here and take the common base as v1 v2. So what you will get is d1 plus d2 into v1 v2 upon d1 v2 plus d2 v1. Simple. Let's practice the next example. A person moves first 1/3 of total distance with a speed v1. A person moves first 1/3 of the total distance traveled with a speed v1 and remaining 2/3 in two equal interval of time with speed v2 and v3. You need to determine the average speed of person. So the person travels first 1/3 of the total distance with a speed v1 and the remaining 2/3 in two equal interval of time with speed v2 and v3. We need to determine the average speed of the person. So assume that the person travels a total distance d. If the person travels a total distance d, then the first 1/3 of the total distance will be d by 3. If the person travels the first 1/3 distance d by 3 with a speed v1, then the time taken to travel it will be the distance upon speed, which is v1. So the time taken to travel the first 1/3 distance will be d by 3 v1. So the time taken to cover the first 1/3 distance with the speed v1 is nothing but d by 3 v1. Then we know that the person travels the remaining 2/3 of the distance. If the total distance traveled is d, then the remaining 2/3 will be 2d by 3. And the person travels this remaining 2d by 3 in two equal interval of time with speed v2 and v3. So let's say those two equal interval of time are t and t. So assuming he travels the remaining in a time 2t. So for out of time 2t, for time t, the person travels with speed v2 and for remaining time t, the person travels with a speed v3. So if we visualize the whole motion, the person travels a total distance t in such a way that the person travels the first distance d by 3 with a speed v1 and the remaining distance 2d by 3 in two equal interval of time. So let's say those two equal interval of time are t and t, and the person moves for these two time frame of t and t with speed v2 and v3. So from here, looking at the later half part, I can say this distance traveled, which will be v2t, the speed is v2, time is t, v2t, plus this distance traveled, which will be v3t, will be equal to 2d by 3. So we can say that v2t plus v3t equals to 2d by 3. From here we can find out the value of t. So if you take t common on the left hand side, you get v2 plus v3 times t. So t equals to nothing but 2d by 3 divided by v2 plus v3. So we have got the value of t. Now the question is over. What is the mission? The mission is to find the average speed. Average speed is nothing but the total distance traveled upon total time taken. The total distance traveled we have assumed is d. What will be the total time taken? To travel the first distance d by 3, the time taken is d by 3 v1. To travel the next distance 2d by 3, we have assumed that the time taken is 2t, where we already know what is the value of t. So we can say the average speed will be the total distance traveled d upon the total time taken. The total time taken will be d by 3 v1 plus 2t. And in place of t, we can substitute 2d by 3 times v2 plus v3. On solving, we can cancel out d. Take the common denominator here, 3v1 into v2 plus v3, and rearrange. We will get the answer as 3v1 times v2 plus v3 upon v2 plus v3 plus 4v1. Try to solve this on your own. Moving on. Now let's talk about the most important thing a child should know in motion in 1D, that is acceleration. So let's discuss acceleration. What is acceleration? Sir, the acceleration is the rate of change of velocity with respect to time. The infinitely small change in velocity upon the infinitely small change in time in which that infinitely small change in velocity takes place. So the instantaneous acceleration of a particle is nothing but dv by dt. So we say the rate of change of velocity with respect to time is called acceleration. We can write acceleration as dv by dt. But we know that v, which is velocity, is nothing but the rate of change of position with respect to time. So here in place of v, we can even substitute dx by dt. So we get acceleration can also be written as the rate of change of position with respect to time. So we know that we can write d of dy by dx as d square y by dx square. Do the same thing here. You can even write acceleration as d square x upon dt square. So acceleration can be written as the rate of change of velocity with respect to time, or d square x upon dt square. There is one more way to write acceleration, and that comes from the elimination of time from the definition of acceleration and velocity. We know that acceleration is dv by dt. Yes, sir. We know that velocity is dx by dt, right? If we eliminate time from these two, if I find out the value of dt from second equation and put it in first equation, or I find out the value of dt from first equation and put it in second equation, we can get one more correlation of acceleration, and that is really important. Let's find it out. Also, as v equals to dx by dt and a equals to dv by dt, from time elimination, we get that acceleration equals to dv upon dx by v. Sir, how do you get? Look at the first one. From here, you can say that dt equals to dx by v, right? Now, in place of dt, in the second one, substitute dx by v. So what you get is a equals to dv upon dx by v. This v moves from denominator of denominator into the numerator. So the acceleration comes out to be equals to v dv by dx. So now we can say finally, and you need to remember it, acceleration can be written as dv by dt, can be written as d square x upon dt square, or acceleration can be written as v dv by dx. So these are the three ways in which we write acceleration, and you need to remember them. But when we say that acceleration of a body is 4 meters per second square, what you should think? Do not think of acceleration as 4 meters per second square. Think of it as 4 meters per second per second. Sir, aren't they the same thing? 4 meters per second per second? No. When you think of 4 meters per second square, you do not visualize anything. When you think of 4 meters per second, you visualize something. You can say that if the acceleration is 4 meters per second, it means that the velocity will increase in the direction of acceleration. The velocity will increase in the direction of acceleration by 4 meters per second every second. So every second in the direction of acceleration, the velocity will increase by the magnitude same as acceleration. Sir, haven't got it. Do not worry. Let's see it from an example. If a person accelerates from velocity of 10 meters per second with an acceleration of 4 meters per second square in the direction of acceleration, what will be the velocity of person at time equals to 1 second, 2 second, 3 second and 4 second. So initial velocity of person is 10 meter per second and the acceleration of the person is 4 meter per second square in the direction of acceleration. I told you guys, whenever you see 4 meter per second square, do not think of 4 meter per second square as 4 meter per second square. Think of 4 meter per second square as 4 meter per second per second. It means that in every single second, the velocity will increase in the direction of acceleration by 4 meter per second. In every single second, the velocity will increase in the direction of acceleration by 4 meter per second. So let's visualize this person. At time equals to 0, this person has got velocity of 10 meter per second. In 1 second, the velocity will increase by how much? So acceleration is 4 meter per second square. That is 4 meter per second per second. When the acceleration is 4 meter per second square, in 1 second, the velocity will increase by 4 meter per second. The velocity was already 10 meter per second. In 1 second, it will increase by 4 meter per second. So what will be the velocity at time equals to 1? So sir, velocity was already 10. As the acceleration is 4 meter per second square, every second the velocity increases by 4 meter per second. So it was already 10. In 1 second, it will increase by 4. So at time equals to 1 second, the velocity of this person will be 14 meter per second. What will be the velocity of this person at time equals to 2? Sir, acceleration is 4 meter per second per second. When the acceleration is 4 meter per second, it means that every single second the velocity increases by 4 meter per second. So if in 1 second the velocity increases by 4 meter per second, in 2 seconds the velocity will increase by how much? So sir, in 2 seconds the velocity will increase by 8 meter per second. Initially the velocity was 10. The acceleration is in direction of initial velocity. In 1 second, the velocity increases by 4. In 2 seconds, the velocity will increase by 8. Velocity increases by 4 meter per second every second. So in 2 seconds, the velocity will increase by 8. Already it was 10. It will increase by 8 and hence it will become 18 meter per second. So at time equals to 2, velocity will be 18. What will be the velocity at time equals to 3? So now I know acceleration is 4 meter per second per second. It means that every single second the velocity increases by 4 meter per second in the direction of acceleration. So in 3 seconds the velocity will increase by 4 into 3, that is 12 meter per second. Already the velocity was 10. In 3 seconds the velocity will increase by 12 meter per second. So what will the velocity become? So already the velocity was 10. In 3 seconds the velocity will increase by 12. Already it was 10. It increases by 12. So it becomes 10 plus 12, that is 22 meter per second. So at time equals to 3, the velocity will be 22 meter per second, and so the velocity keeps on increasing. So this example was used to explain what is the definition of acceleration and what is the meaning when I say that acceleration is 4 meter per second square. You know what we have used here is the first equation of motion. How? Let's see. You will say that as the acceleration is 4 meter per second square, that is 4 meter per second, so every second the velocity increases by 4 meter per second. Every single second the velocity of this person will increase by 4 meter per second. At time equals to 1 second, what will be the velocity? So every second, since the velocity increases by 4 meter per second, at time equals to 1 second, velocity will be equals to initial plus 4 because it increases by 4. So already it was 10, it increases by 4, so that becomes 14 meter per second. At time equals to 2 seconds, the velocity will be equal to, in 2 seconds, the velocity will increase by 8. So the final velocity will be 10 plus 4 into 2. In 1 second increases by 4, in 2 seconds increases by 8. So that will be 18 meter per second. At time equals to 3 seconds, in 3 seconds the velocity would have increased by 3 into 4, that is 12. So the velocity will be equal to 10 plus 4 into 3, that is 22. At time equals to 4, the velocity will be equals to initial 10 plus 4 into 4. 4 into 4 is 16. 16 plus 10 gives you 26 meter per second. At time equals to t second, what will be the velocity? So you will say, sir, acceleration is 4 meter per second per second. So every second velocity increases by 4. In 1 second it increases by 4 into 1. In 2 seconds it increases by 4 into 2. In 3 seconds it increases by 4 into 3. In 4 seconds it increases by 4 into 4. In t second it will increases by 4 into t. So if in time frame t the velocity increases by 4t, what will be the final velocity? So you will say, sir, it increases by 40. It was already 10. It increased by 40. So the final value have to be initial value 10 plus 40. Now what you see right here is nothing but u plus 80. The final velocity v equals to initial velocity 10 plus acceleration 4 into the time. So this is nothing but v equals to u plus 80. So we have just learned the first equation of motion. Let's continue. If the initial speed is 10 meter per second and acceleration is 4 meter per second square, what will be the displacement up to time equals to 1 second, 2 second, 3 second, 4 second? How to find displacement up to time equals to 1 second, time equals to 2 second, time equals to 3 second, time equals to 4 second? What to do? So let's see. At time equals to 0, speed is 10 meter per second. At time equals to 1, speed is 14 meter per second. At time equals to 2, speed is 18 meter per second. At time equals to 3, speed is 22 meter per second. And at time equals to 4, the speed is 26 meter per second. Our mission is to find the displacement till time equals to 1 second, 2 second, 3 second, 4 second. Can I use here displacement equals to velocity into time? Let's say I wish to find what is the displacement from time equals to 0 till time equals to 1. If I need to find what is the displacement from time equals to 0 to time equals to 1. Can for this time frame of 1 second, can I take the velocity to be 10 meter per second? For this time frame of 1 second, can I take the velocity to be 10 meter per second? So that is the velocity at the beginning of this time frame. That is the velocity at time equals to 0. As the time changes from 0 to 1, the velocity is continuously increasing. So you can't take 10 meter per second as the velocity for the entire journey. Why? Because it is the initial velocity. During the entire journey, the velocity is 10 nowhere after the initial time. Okay. For this time frame of 1 second, can I take the velocity of person to be 14 meter per second? Sir, this is uniformly accelerated motion. From time equals to 0 till time equals to 1, the velocity is continuously increasing. The velocity is 14 only at the very end. The velocity is 10 at the very beginning. Velocity is 14 at the very end. So for this time frame of 1 second, what should I take the velocity? Should I take it 10? No, that's the initial velocity. Should I take it 14? That is the final velocity. And the velocity keeps on changing. So what should I take the velocity to be for this time frame of 1 second? It's easy. I taught you guys, if y is a linear function of x, then the average value of y over a range of x is given by nothing but the initial value of y plus final value of y by 2. But you can do this only when y is a linear function of x. When a particle has constant acceleration, its velocity increases linearly. Sir, how do you know? Beta, v equals to u plus at. The graph is a straight line. Y equals to m x plus c. This is a straight line. So just remember, for uniformly accelerated motion and only for uniformly accelerated motion, you can say that the average velocity equals to initial plus final by 2. Once more, for uniformly accelerated motion only, you can use average velocity equals to initial plus final by 2. So starting here, for the first second, what will be the average velocity of person? For the first second time frame, you shouldn't take the velocity to be 10, you shouldn't take the velocity to be 14. For the first second time frame, the average velocity will be 10 plus 14 by 2. 10 plus 14 by 2 becomes 24 by 2, that is 12 meter per second. So if the time frame is 1 second and the average velocity for this 1 second is 12, what will be the displacement? So you will say the displacement from time equals to 0 till time equals to 1 is nothing but the average velocity from time equals to 0 till time equals to 1, which is 12 times the time frame. Displacement equals to average velocity into time frame. So 12 into 1, that is 12. Now read the next one carefully. From time equals to 0 till time equals to 2. For this 2-second time frame, what will you take the average velocity? So you will say, sir, for this 2-second time frame, at the very beginning of this 2 second, the velocity is 0. Sorry. At the very beginning of this 2 second, the velocity is 10. At the very end of this 2 second, velocity is 18. So for this 2-second time frame, I will take the average velocity to be 10 plus 18 by 2. So the average velocity is 10 plus 18 by 2. So the average velocity will be 28 by 2, and 28 by 2 is 14 meter per second. So the average velocity has to be 14 meter per second. Now the question is, what will be the displacement from time equals to 0 till time equals to 2? So you will say the average velocity for this 2-second time frame is 14 meter per second and the time frame is 2. So displacement has to be equals to average velocity into time. Average velocity for this 2-second time frame came out to be 14 and the time frame is 2. So the displacement comes out to be 14 into 2, that is 28 meter. Next question. What will be the displacement from time equals to 0 till time equals to 3? Now for these 3-second time frame, I need to find the average velocity. At the very beginning of this 3-second time frame, velocity is 10 meter per second. At the very end of this 3-second time frame, velocity is 22 meter per second. For these 3-second time frame, I can't take the velocity as 10 meter per second. For this 3-second time frame, I can't take the velocity as 22 meter per second. So for this 3-second time frame, the average velocity should be treated as 10 plus 22 by 2. So 10 plus 22 by 2 gives you 32 by 2, and 32 by 2 is 16 meter per second. Now the particle moves for 3 seconds with an average velocity of 16 meter per second. The particle moves for 3 seconds with an average velocity of 16 meter per second. What will be the displacement? So you will say, sir, displacement has to be average velocity into time. For these 3 seconds, the average velocity is 16 and the time frame is 3. So the displacement has to be 16 into 3, that is 48. Now let's do the last one. What is the displacement from time equals to 0 till time equals to 4? So from time equals to 0 till time equals to 4. For these 4-second time frame, at the very beginning, that is at time equals to 0, velocity is 10 meter per second. At the very end of this 4 second, the velocity is 26. So the average velocity for this 4-second time frame, the average velocity for this 4-second time frame shouldn't be treated as 10. Why? Because that was the velocity at the very beginning. Shouldn't be treated as 26. That was the velocity at the very end. This is uniformly accelerated motion. Velocity is continuously increasing. So what should we take the average velocity for this 4-second time frame? Nothing but initial plus final by 2. That will be 10 plus 26 by 2. 10 plus 26 is 36. 36 by 2 is 18. So we get 18 meter per second. So for these 4-second time frame, the average velocity is 18 meter per second. The average velocity is 18 meter per second and the time frame is 4 seconds. So looking from time equals to 0 to time equals to 4, you will say the particle moves for 4 seconds with an average velocity of 18 meter per second. If the particle moves for 4 seconds with an average velocity of 18 meter per second, what will be the displacement? So sir, displacement will be equal to the average velocity in this 4-second duration, which is 18 multiplied by the time, which is 4. 18 into 4 is nothing but 72 meter. Okay, sir. Next question. At time equals to 0, velocity of person is 10 meter per second. At time equals to t, the velocity of this person will be 10 plus 40. The same. Last example, initial velocity 10 and acceleration equals to 4 meter per second per second. So if I ask you, tell me what will be the displacement of this person in time t? You have found in 1 second, 2 second, 3 second, 4 second. Tell me a generalized answer. What will be the displacement of this person in time t? So you will say, sir, at time equals to 0, velocity is 10. And at time equals to t, velocity is 10 plus 40. If you are not getting it, why it is 10 plus 40, think of v equals to u plus at. Right? Initial velocity 10, acceleration 4 into t. Orbital, you can think that as the acceleration is 4 meter per second square, that is 4 meter per second, you can think that every single second the velocity increases in the direction of acceleration by 4 meter per second. So in 1 second increases by 4, in 2 seconds increases by 8, in 3 seconds increases by 4 into 3, that is 12, in 4 seconds increases by 4 into 4, that is 16. So in t second increases by 40. It increases by 40. It was already 10, so the velocity has to be 10 plus 40. Now we need to find this displacement. From time equals to 0 till time equals to t, how will you write the average velocity? For this whole time frame t, you can't take the velocity to be 10. That is initial. You can't take the velocity to be 10 plus 40. That is the final. The average velocity for this t second time frame will be initial plus final by 2. So that will be 10 plus 10 plus 40 by 2. 10 plus 10 plus 40 by 2 gives you nothing but 10 plus 40 by 2. Right? This becomes 20 plus 40 by 2. That can be written as 10 plus 40 by 2. Sir, why don't you write 10 plus 2t? I have kept it this way for some purpose. Okay. So this becomes 10 plus 40 by 2. The displacement in this time frame t will be equal to average velocity in this time frame t multiplied by t. The average velocity is 10 plus 40 by 2 and the time frame is t. So the displacement comes out to be 10 plus 40 by 2 into t. If I multiply t here and here, what I get is the displacement comes out to be 10t plus half into 4 into t square. Check it. 10t plus half 1 by 2 into 4 into t square. Right? Now this itself is nothing but x equals to ut plus half a t square. The initial velocity is 10. The acceleration is 4. And I am asking you displacement at any time t. So that came out to be 10t plus half into 4 into t square, which is nothing but x equals to ut plus half a t square. So the next example, a person has velocity of 20 meter per second towards positive x and acceleration of 2 meter per second square towards negative x. So velocity of 20 meter per second towards positive x and acceleration of 2 meter per second square towards negative x. Then find the velocity and displacement till time equals to 4. As per the problem statement, the person has got velocity of 20 meter per second towards positive x and acceleration of 2 meter per second square towards negative x. I taught you guys, always think of acceleration not as 2 meter per second square, think of it as 2 meter per second per second. So when I say that acceleration is towards negative x equals to 2 meter per second square, it means that acceleration is towards negative x equals to 2 meter per second per second. When I say that acceleration of 2 meter per second is towards negative x, it means that in the negative x direction, the velocity will increase by 2 meter per second every second. In the negative x direction, the velocity will increase by 2 meter per second every second. And the increase of velocity in negative x direction is as good as decrease of velocity in positive x direction. The increase of velocity in negative x direction is as good as decrease of velocity in positive x direction. Once more, the increase of velocity in negative x direction is as good as decrease of velocity in positive x direction. So let's start solving this question. This is the person. At time equals to 0, person has got velocity of 20 meter per second towards positive x and acceleration of 2 meter per second square towards negative x. If the acceleration is 2 meter per second square towards negative x direction, it means it is 2 meter per second towards the negative x direction. So the acceleration is 2 meter per second towards the negative x direction. Now, hence the velocity will increase by 2 meter per second in negative x direction. Hence the velocity will increase by 2 meter per second in negative x direction or will decrease by 2 meter per second in positive x direction every second. So every single second the velocity will increase by 2 meter per second in negative x direction or will decrease by 2 meter per second in positive x direction. So we will say every second the velocity increases backward by 2. It decreases forward by 2. So can you tell me what will be the velocity at time equals to 1 second? Yes sir, quite easy. In 1 second, the velocity increases towards negative x by 2. So it decreases towards positive x by 2. So it will decrease by 2. Already it was 20. It will decrease by 2. It will be 18 meter per second. Can you tell me what will be the velocity at time equals to 2 seconds? Sir, at time equals to 2 seconds. In 2 seconds, the velocity will increase in the negative x by 4. So it will decrease in the positive x by 4. So it will be 16 meter per second. If I ask you what will be the velocity at time equals to 3. So you will say, sir, in 3 seconds, the velocity will increase in negative x by 6. 2 into 3, 6. Or will decrease in the positive x by 6. So 20 minus 6 will be 40. Now, can you tell me what will be the velocity at time equals to 4? So you will say, sir, till time equals to 4. In 4 seconds, the velocity will increase in negative x by 8. The velocity will increase in negative x by 8 or will decrease in positive x direction by 8 meter per second. Already the velocity was 20. It will decrease by 8. So the final velocity at time equals to 4 has to be 12 meter per second. You can do all these things orally without even raising pen. So acceleration is backward 2. So every second the velocity increases backward by 2. So in 4 seconds the velocity increases in backward direction by 8. So in forward decreases by 8. Already was 20, will decrease by 8. So will become equal to 12. So in 4 seconds the velocity will decrease by 8 and will become equal to 12. Now our mission is not at all to find the velocity at time equals to 4. Our mission is to find the displacement till time equals to 4. So for this 4-second time frame, from time equals to 0 till time equals to 4. So for this 4-second time frame, what should I take the velocity should be? Should I take it as 20? No, sir, that was the initial velocity. Should I take it as 12? No, sir, that is the velocity at the very end. So the average velocity for this 4-second time frame will be equal to 20 plus 12 by 2. And 20 plus 12 by 2 is 32 by 2, and 32 by 2 is 16 meter per second. So you should treat the velocity to be average 16 meter per second for this 4-second time frame. So what will be the displacement? Displacement has to be equals to average velocity into time. The average velocity for this 4-second time frame is 16. The time frame is 4, so you get 16 into 4, that is 64 meter. Or sir, you can simply use x equals to ut plus half at square. If you take the direction towards right as positive, so you'll write the displacement equals to initial velocity as plus 20 into the time, which is 4, plus half times acceleration is in negative direction, so it will be taken as minus 2 into the time frame square, that is 4 square. If you solve this, you will get the same result, 64. Okay, let's do one more example. A car is moving with speed of 20 meter per second, undergoes a deceleration of 4 meter per second square. Determine the distance traveled by a car before coming to rest. So what will be the distance traveled by this car till the time it comes to rest? So the car has got velocity of 20 meter per second. The car has got deceleration of 4 meter per second square. And they are asking you what is the distance traveled by this car till the time it comes to rest. Can you tell me how much time it will take for the car to come to rest? The acceleration is 4 meter per second square, yes. So every single second the velocity will increase in negative x direction by 4 meter per second. So every single second the velocity will decrease in positive x direction by 4 meter per second. At time equals to 0, the velocity in positive x direction is 20. At time equals to 1, as the acceleration is 4 meter per second square backward, every single second the velocity will increase by 4 meter per second backward. So the velocity will decrease by 4 meter per second forward. So at time equals to 1, the velocity will be 16. At time equals to 2, in the next time frame of 1 second, due to the acceleration, the velocity will decrease further by 4 and the velocity will be 12. At time equals to 3, it will decrease further by 4 and will be equal to 8. At time equals to 4, it will decrease further by 4 and will be equal to 4. And time equals to 5, the velocity becomes 0. So we know it will take 5 seconds for this car to come to rest. As the rate of change of velocity is 4 meter per second square, every second the speed decreases by 4 meter per second. So how much time it will take for this car to come to rest? So you will say, sir, initial velocity is 20 and every second the velocity decreases by 4 meter per second. So it will take 5 seconds for the velocity to drop to 0. Hence, it will take 5 seconds for the car to stop. The average velocity for these 5-second time frame will be how much? So at time equals to 0, the velocity is 20. At time equals to 5, the velocity will drop to 0. So what will be the average velocity for this 5-second time frame? So you will say the average velocity for this 5-second time frame is initial 20 plus final 0 by 2. So the average velocity for this 5-second time frame is nothing but 10 meter per second. If the car moves with an average velocity of 10 meter per second, if the car moves with an average velocity of 10 meter per second for 5 seconds before coming to rest, what will be the displacement of the car? So the car moves with an average velocity of 10 meter per second for 5 seconds before coming to rest. So the average velocity of car is 10 meter per second, time frame is 5, so the displacement will be equal to average velocity into time. So the displacement will be equal to 10 into 5, which is 50 meters. So this car will travel 50 meters before coming to rest. So now we will do the derivations of the equation of motion, which is v equals to u plus at, x equals to ut plus half at square, or v square minus u square equals to 2s. So let's start with the first one. From the definition of acceleration, we know that acceleration is the rate of change of velocity with respect to time. A equals to dv by dt. I can bring this dt up here and write dv equals to a dt. Integrating both the side is a valid operation, so we can integrate both the side. The lower limit of velocity being u, because the initial velocity is u, that's called u, and the final velocity v. And integrating time from 0 to t. So we can write, if we know a equals to dv by dt, we can even write integral dv from lower limit u to upper limit v equals to integral a dt from the lower limit of time 0 to upper limit of time t. Only for the case of uniformly accelerated motion. When I say that uniformly accelerated motion, when you have got a uniform acceleration, it means that the acceleration during the motion is constant. And we have learned that if we have got a constant within the integration, we can take it out of the integration. So only for the case of uniformly accelerated motion, when acceleration is constant, you can take it out of the integration. Once you take it out of the integration and integrate, you will get integral dv equals to a times integral dt. The limit on dv, lower limit u, upper limit v, and limit on dt, lower limit 0, upper limit t. Integral dv gives you v, integral dt gives you t. So you will say v, lower limit u, upper limit v, equals to a times integration of dt, which is t, lower limit 0, upper limit t. Always substitute upper limit minus lower limit. So in place of v, first substitute the final velocity v minus the initial velocity u. So you get v minus u equals to a times upper limit t minus lower limit 0, t minus 0 becomes t, so you get v minus u equals to at. Or you can bring this u to the right hand side and write v equals to u plus at. While the derivation of v equals to u plus at, we have made an assumption, and the assumption is that this acceleration is constant. That's why we took it out of the integration, right? So you should apply the equation v equals to u plus at only for the case of uniformly accelerated motion. Moving on. From the definition of velocity, we know that velocity equals to dx by dt. For the case of uniformly accelerated motion, you can write velocity as u plus at. So you can say as velocity equals to dx by dt, we can even say dx equals to velocity into dt, just multiplying dt here. So dx equals to velocity into dt. Now in place of velocity, we can substitute u plus at. So we get that dx equals to u plus at into dt. You can write in place of velocity u plus at when? In place of instantaneous velocity, you can write initial velocity plus acceleration into time only when it is under uniformly accelerated motion, because this condition came assuming the acceleration to be constant, right? So once you have got dx equals to u plus at into dt, now multiply dt here and integrate. So what we get is dx equals to u dt plus at dt. Integrating each term, we get integral dx from 0 to x equals to integral u dt from 0 to t plus integral at dt from 0 to t. As the initial velocity can't change during the motion, it is a preset quantity at the beginning of the motion, u is constant. And as we are solving for uniformly accelerated motion, a is also constant. So you can bring both of them out of the integration. And then integrating, integration of dt gives you t, and integration of t dt gives you t square by 2. So you get integration of dx x, lower limit 0, upper limit x, equals to u take outside, integration of dt gives you t, lower limit 0, upper limit t. Take a outside here, integration of t dt gives you t square by 2, lower limit 0, upper limit t. After substituting upper limit minus lower limit, we get that x minus 0 equals to u into t minus 0 plus a into t square minus 0 square by 2. So you get x equals to ut plus half at square. This is the second equation of motion. Now let's talk about the third equation. We know that velocity equals to dx by dt. Yes, sir. This is the basic definition of velocity, the rate of change of position with respect to time. And we know that acceleration equals to dv by dt, because acceleration is the rate of change of velocity with respect to time. From the time elimination from these two, which we did at the very beginning while explaining you acceleration, if we do the time elimination, we can write a equals to v dv by dx. Take out the value of dt from anyone and substitute into the other. You will get acceleration can be written as v dv by dx. Bring the dx here and multiply. So you can write v dv equals to a dx. Now integrate both the sides. So you will say integral v dv from lower limit u to upper limit v equals to integral a dx from lower limit 0 to upper limit x. You can bring the a outside of integration only when you are solving for uniformly accelerated motion. As again I am taking a out of the integration, I should apply the third equation of motion also only for uniformly accelerated motion. So you will say integral of v dv gives us v square by 2. Integral of a dx, if a is constant, take it outside. Integral of dx gives you x. So you get v square by 2, lower limit u, upper limit v, equals to a x, lower limit 0, upper limit x. Substituting upper limit minus lower limit, you get v square minus u square by 2 equals to a times x minus 0, that becomes x. Now bring this 2 to the right hand side. What we get is v square minus u square equals to 2ax, and this is the third equation of motion. One should apply all the three equations of motion only for uniformly accelerated motion when the acceleration is constant. So now we will talk about displacement in nth second. First thing, we need to understand what is the meaning of nth second. What is the meaning of fifth second? Let's take an example. If I say that in the first hour of lecture, we are going to study this. What is the meaning of first hour? So you will say, sir, first hour means that time equals to 0 till time equals to 1 hour. If I say in the second hour, we will talk about this particular subtopic. So you will say, so second hour of lecture means that time equals to 1 hour to time equals to 2 hours. Similarly, what is the meaning of first second? You will say that, sir, first second means time equals to 0 to time equals to 1 second. Similarly, second second means time equals to 1 to time equals to 2 seconds. Third second means time equals to 2 to time equals to 3 seconds. Fourth second means time equals to 3 to time equals to 4 seconds. Fifth second means time equals to 4 to time equals to 5. So what are you trying to do here? I'm trying to make you understand the meaning of displacement in nth second. But before that, I want you to understand the meaning of nth second. So first second means 0 to 1, second second means 1 to 2, third second means 2 to 3, fourth second means 3 to 4, fifth second means 4 to 5. Then can you tell me what will be the meaning of nth second? Look at this idea. So nth second has to be time equals to n minus 1 to time equals to n. Now let's say a person starts the journey with constant acceleration. Your mission is to find the displacement in nth second. So displacement in nth second means the displacement from time equals to n minus 1 till the time equals to n. How to find the displacement in this nth second? So you will say the displacement in nth second can be easily found just by finding the displacement up to time equals to n and finding the displacement up to time equals to n minus 1. So we can say the displacement in nth second is same as displacement up to time equals to n minus displacement up to time equals to n minus 1. So we can say displacement in n second equals to displacement up to time equals to n minus displacement up to time equals to n minus 1. From the second equation of motion, we know that displacement equals to ut plus half a t square. If you need to find displacement up to time equals to n, in place of t, substitute n. So displacement up to time equals to n will be nothing but un plus half into acceleration into n square. The displacement up to time equals to n minus 1 will be equal to u into n minus 1 plus half into a into n minus 1 whole square. So substitute the data, you will get the displacement in n second equals to displacement up to n second minus the displacement up to n minus 1 second. So that will be un plus half a n square minus un minus 1 plus half a n minus 1 whole square. On solving this expression, we get that displacement in n second equals to u plus a by 2 into 2n minus 1. So you need to remember this formula, that the displacement in nth second is given by u plus a by 2 into 2n minus 1. Do remember that displacement is a vector quantity. So here the x is not at all distance traveled, x is the displacement. So let's do a quotient based on this. A car is traveling with speed of 10 meter per second in the positive x direction with an acceleration of 4 meter per second square, also in positive x direction. So the velocity and acceleration are in same direction. Determine the displacement of the car in 10th second. It is not 10 second, it is 10th second. So here we have the car. The car has got acceleration of 4 meter per second square and initial velocity of 10 meter per second. First, we need to understand the meaning of 10th second. Beta, 10 second means time frame from time equals to 9 to time equals to 10. This is called 10 second. But here we are not going to find displacement up to time equals to 10 and then subtract displacement up to time equals to 9 to get the answer. We now already know the formula that displacement in nth second is given by u plus a by 2 into 2n minus 1. So simply apply it. You will say that displacement in nth second equals to u plus a by 2 into 2n minus 1. In the question, everything is given u, a, n. You will say that the initial velocity u is 10 meter per second. The acceleration a is 4 meter per second square and n is nothing but 10. So when you substitute, you get here 10 plus 4 by 2 into 2 into 10 minus 1. 2 into 10 becomes 20. 20 minus 1 becomes 19. And here 4 by 2 you get a 2. So you get 10 plus 2 into 19. 2 into 19 is 38. 38 plus 10, that becomes 48 meter. So now we will solve 3 questions based on the third equation of motion. The two ends of a train undergoing uniform acceleration crosses a pole with speed u and v. The two ends of a train undergoing uniform acceleration crosses a pole with speed u and v. Determine the speed of train when 1/3 length of the train has crossed the pole. So this is a simple question, but before we solve it, let's visualize it. So let's say this is the train and this is the pole. When the front of the train crosses the pole, the speed of the train is u. And when the end of the train crosses the pole, the speed of the train is v. We need to find what is the speed of the train when 1/3 length of the train has crossed the pole. Let's say this speed is v dash. We need to find v dash. I will take the direction towards right as positive. When I say that I will take the direction towards right as positive, the velocity, the acceleration, the displacement towards right will be taken as positive, while the velocity, acceleration and displacement towards left will be taken as negative. So first thing, assuming the velocity when 1/3 length has crossed to be v dash and applying the third equation of motion. So from where to where? From the very beginning when the train started to cross the pole to the very end when the train has completely crossed the pole. We will say that the final velocity square minus the initial velocity square equals to 2 times acceleration into displacement. Here you might observe that I have taken V, U, A, L, all four of them positive. And the reason is that all four of them are in the direction I have assumed to be positive, that is towards right. Now we can make the third equation of motion again from the very beginning till 1/3 length has crossed. So we will say after 1/3 length has crossed, the final velocity is V dash, the initial velocity is U, the acceleration is A, and the displacement is L by 3. So again making the equation, I can say V dash square minus U square equals to 2AL by 3. Our mission is to find V dash. How to find V dash? So sir, divide the equations both the side. When you divide the equations both the side, on the left hand side you will get V square minus U square upon V dash square minus U square. And on the right hand side you can see that this 2AL will get cancelled. So on the right hand side you will get 1 upon 1 by 3. And sir, 1 upon 1 by 3, the 3 moves from denominator to the numerator and you get 3. So on solving you get that V square minus U square upon V dash square minus U square equals to 3. Once this is done, game over. Now all you have to do is cross multiply and solve. So you can write from here V square minus U square equals to 3V dash square minus 3U square. So our mission is to find V dash. Bring this minus 3U square to the left hand side. So on the left hand side you get V square plus 2U square equals to 3V dash square. Now you can move this 3 down. So you get V dash square equals to V square plus 2U square by 3. So I can write V dash square equals to V square plus 2U square by 3. Now just take the under root. So the speed after crossing 1/3 length, which is V dash, comes out to be under root of V square plus 2U square by 3. Simple question. Let's practice another one. When a bullet crosses a plank, the speed of the bullet becomes 1 by n times. Find the number of identical planks to be placed so as to stop the bullet. So when the bullet crosses one plank, its speed becomes 1 by n times. How many planks have to be placed to stop the bullet? So let's say this is the case. After crossing one plank, the speed of the bullet becomes 1 by n times. Let's say the thickness of one plank is t, and let's assume we have to place x identical planks to stop the bullet. The question is asking me how many identical planks have to be placed to stop the bullet. So let's say I say x planks. If when the bullet tries to cross x planks, the bullet stops, it means that the thickness that the bullet will have to travel is nothing but xt. Now all we have to do is we have to apply the third equation of motion twice. First for the first case when the bullet crosses one plank, and then for the second case when the bullet crosses x planks. So x planks have to be placed to stop the bullet. If the thickness of one plank is t, then the thickness of combination of x plank has to be xt. Now just make third equation of motion taking direction towards right as positive. For the first case, you will make the third equation of motion as the final velocity square v by n square minus initial velocity square equals to 2 times acceleration into displacement. Notice that I have taken final velocity as positive v by n. I have taken initial velocity v as positive. I have taken acceleration as negative because when the bullet tries to cross the plank applies force on the bullet in the opposite direction, because of which the velocity of bullet decreases. So the acceleration is towards left. That's why it has been taken as negative into t. Now make the third equation of motion again for the combination of x planks. So you will say the final velocity square minus initial velocity square equals to 2 times acceleration, which is minus a, times displacement, and here the bullet crosses the combination of x plank. So the displacement is xt. Once this is done, game over. Now all you have to do is divide both the side. When you divide both the side, on the left hand side you get v by n whole square minus v square upon 0 minus v square equals to Cancel out 2, 2, minus a, t, and on the right hand side you get 1 by x. If you cancel out v square from both numerator and denominator, you can write numerator as v square times 1 by n square minus 1 upon minus v square. Cancelling out v square, in denominator you get minus 1. Multiplying minus 1 to numerator, you get the left hand side to be 1 minus 1 by n square equals to 1 by x. So not at all a tough case to solve. So dividing both the side, on the left hand side v square get cancelled. On the left hand side you get 1 by n square minus 1 upon 0 minus 1. So the denominator becomes, numerator is 1 by n square minus 1, denominator is 0 minus 1 because we have cancelled out v square. And on the right hand side 2 minus a t get cancelled, and on the right hand side you simply get 1 by x. So this thing can be rewritten as 1 minus 1 by n square multiplied minus 1 in the numerator here and the denominator. So you get 1 minus 1 by n square by 1, that becomes 1 minus 1 by n square equals to 1 by x. This can be written as n square minus 1 by n square equals to 1 by x. Now flip it both the side. So the number of plates required to completely stop the bullet is n square upon n square minus 1. Now let's practice one more question based on third equation of motion. So now the third question. If after crossing a plank, the speed of bullet reduces by 1 by n times of its initial, determine the number of planks to be placed to stop the bullet. After listening to this question, students feel like, sir, we have already done this question, you are repeating it. No, there is one small change in the question and the whole question has been changed. Now the question is, if after crossing one plank, the speed of the bullet reduces by 1 by n times. Reduces by 1 by n times. In the last question, we did becomes 1 by n times. This time I am saying reduces by 1 by n times. So determine the number of planks to be placed to stop the bullet. So you need to visualize this case. Let's say one plank has got thickness t. After crossing the plank, the velocity reduces by 1 by n times. So if the initial velocity was v at the time of entering, at the time of exiting, velocity will be v minus v by n, reduces by 1 by n times. Now let's say we have to place x planks to stop it. Now we are going to make the third equation of motion twice, just like in the last question. From here, the first case, from initial to final, I will say the final velocity whole square minus the initial velocity whole square equals to 2 times acceleration minus a into the displacement t. And for this second case, when we have placed x planks, so as to stop the bullet, I will write the final velocity whole square minus the initial velocity whole square equals to 2 times acceleration into displacement, that is xt. If I divide it both the side, this 2 minus at will get cancelled. So we can write from here v minus v by n whole square minus v square upon 0 minus v square equals to minus 2at upon minus 2axt. Cancelling out both the side and taking here v square outside, you will be left with 1 minus 1 by n whole square minus 1 by minus 1 equals to 1 by x. So 1 minus 1 by n whole square equals to 1 by x. If you multiply a minus 1 in denominator and numerator, in the numerator you will get 1 minus 1 by n whole square equals to 1 by x. Now you just need to solve this. Solving is not the difficult part here. So you can write 1 minus n minus 1 by n whole square. You can write this 1 minus 1 by n as n minus 1 by n equals to 1 by x. Or on solving this, you will get 2n minus 1 upon n square equals to 1 by x, or the number of plates to be placed has to be equals to n square upon 2n minus 1. So that's all for now. See you guys in the next hour.